Okay, so let's start with 7.5, and what we can do is we can do some more examples of multiplying special products. So maybe the first one, what we could do is say take 6x minus 2y times 6x plus 2y. Okay. Well, our first term are the same, our signs are opposite, and our last terms are the same. So this looks to be a difference of squares. So we're going to take 6x times 6x and get 36x squared. And then our middle terms all drop out. So then we have minus the last term squared. So 2 times 2 is 4y squared. And then that would be our solution. Again, if you hadn't remembered to do the special product, you could have taken the inner terms and the outer terms as well. And so that would have been a plus 12xy. This would have been a minus 12xy. And when you got to that point, well, those cancel. And so then all you're left with is the first and the last term squared, okay? So let's do 7 minus 5 in the quantity squared. Okay, so this is going to give us a perfect square trinomial. And so what that means is we're going to take square our first term, so 7 times 7 is 49. Then we're going to take a minus, because we have a minus here, so it's going to be a minus term in the middle. 2 times the first term, which is 7, times the second term, which is 5n. And then we're going to have plus, and then 5n squared, so it's going to be 25n squared. Okay. Now we see that this is an n squared, this is going to be an n, and this is just a number. So if we rewrite this in standard form, that's going to be 25n squared. Now here we have 5 times 7 is 35, times 2 is 70, so it's going to be a minus 70n, and then plus a 49. Okay. So rewriting in standard form as I went down and multiplied out this middle term, it gets you this final solution for the 7 minus 5n, the quantity squared. All right, what about, say we have 4y minus 3 times 4y plus 3, okay? So again, we're looking like it's going to be the first term here. It's going to be a and a is the same, b and b is the same. We have opposite signs. So we just square the first one. So 4y, the quantity squared, is going to give us 16y squared. And then minus the last one, 3 squared is 9. And that gives us our final answer. Now, if for some reason we would have had multiplied outer and inner, well, that would have given us 12y. That would have given us minus 12y. Those cancel, and then all would be left was the first and then the last. And so those inner and outers are gone, and we just have first and last. Okay. So it doesn't matter if you forget those things. It's going to really matter only when we start factoring, going backwards, knowing that that's a difference of squares, which then we can write like this. All right. Let's try another one. 4. All right, let's say we have the quantity 2x squared minus 7, and then that whole thing is squared. Okay, so this is another perfect square trinomial because we're squaring a binomial. And so what we're going to do is we're going to take our first term and square it. So 2 squared is 4, x squared squared is going to be x to the 4th. And then we have a minus here, so it's going to be a minus, and it's going to be 2 times our first term, 2x squared, times our second term, which is 7. And then it's going to be plus this one squared. So 7 times 7 is 49. Okay. Now we have to multiply. Well, here it's just going to stay 4x to the 4th. 2 times 2 is 4 times 8. 2 times 2 is 4 times 7 is 28, and it's a negative. We still have the x squared on it, and then plus 49. Okay. So that's what would happen with this. And again, using our equation, we easily put that in there. And if we didn't, what we could have done is we would have had, a minus 14x squared, and then another minus 14x squared, and then those together equaled a minus 28x squared, which is going to be what we have here. And all we did was we just went ahead and took 2 times the a times the b, which is, this is a, this is b here, and we got our final value straight off. All right, So there really aren't a lot of examples with this one. So I think maybe one more we can do just to remember. Maybe we can do one with positive. So maybe we have 3x plus 4, and that whole quantity squared. And let's also think about maybe having a 2x plus 1 times a 2x minus 4. Okay. So on this one, if we do the same thing we did here, because it's a binomial squared, so it's going to be a perfect square trinomial, we'll take 3x times 3x gives us 9x squared, and then plus 2 times 3x times 4, plus, now we have 4 times 4 is 16, and so that gives us 9x squared, plus, now we have 2 times 3 is 6, times 4 is 24x plus 16, and then that would be our perfect square trinomial from that binomial squared. Okay. All right, so then the last one, we have a and a the same. We have a plus, a minus, so we're like thinking already difference of squares, but then we look and our b's are different. And so this makes us go straight back to FOIL. So we'll take first times first, outer and outer, inner and inner, last and last. So 2x times 2x is going to be 4x squared. 2x minus 4 is going to be minus 8x. 1 times 2x is 2x, and 1 times minus 4 is minus 4. So we have 4x squared minus 6x minus 4, and then that will be then our solution to this binomial times this binomial. All right, so that's all the examples I have for 7.5, and hopefully that will help you.